All right, we're going to begin the 5.2 lesson with the small scale builder. Here it's talking about evaluating expressions. So this is going back to a lot of the work that you've done in previous math classes before. So in these questions, they're giving you an equation that has some sort of variable that you have to solve for. And in this case, they're giving us the variable's value. So in this example here, they say they want us to evaluate 7k plus 2 if the value of k is 4. So all we have to do is substitute in k equals 4. So anywhere where there's a k, we're going to put the number 4. So here we have 7 times 4, which gives us 28 plus 2. 28 plus 2 is 30. So now we can evaluate that question. So let's try this check down here. We'll do the first one together here. So they're asking us to evaluate each expression when x is equal to 3. So that means we have 3 times 3 plus 4. 3 times 3 is 9 plus 4, and 9 plus 4 is 13. So we've evaluated that expression. Looking at the next example, we have 5x plus minus 7. That means anytime we see an x, we need to insert the number 3. So we have 5 times 3 minus 7. 5 times 3 is 15 minus 7, and 15 minus 7 gives us 8. So that's how we evaluate for those. Looking down a little bit further here, in the next example, they ask us to solve an equation, find the value of the variable that makes the equation true. So in this case now we're going to rearrange and solve for the value of x. So here we have 3x plus 4 equals 28. So what we need to do is isolate the 3x. We can do that by moving the other number to the side. So the opposite of adding 4, is subtracting 4. If we subtract 4 from both sides, that gets rid of this value right here, and we have the negative 4 on the other side. If we go 28 minus 4, that gives us 24. And then to evaluate for x, we would divide both sides by 3 to get x equals 8. So let's try again these check questions here and solve each equation so we can solve for what the value of x would be. So up above here, we have 3x minus 4 equals 23. In order to get rid of this negative 4, we have to do the opposite, which is adding 4. So I'll do that to both sides. I'm left with 3x. And then on the other side, 23 plus 4, which is 27. And then I can divide both sides by 3. And 27 divided by 3 gives us 9 for a final answer. So x is equal to 9. And for the next one, they don't show you all the steps here, but we're going to go through the same process. So I need to solve for x. That means I have 5x plus 7 minus 7. And on the other side, I also have to subtract 7. Then I'm left with 5x equals 42 minus 7, which is 35. Now I divide both sides by 5 to get a final answer of x equals 7. So that's how we're going to do those ones. All right, moving on to the next lesson on the next page. So continuing on, 5.2 properties of functions. So there's some other very, very important key terms here that are going to be used throughout this course as well as your future math courses. So last lesson, we talked about sets and elements. So remember, a set is a group of objects and an element is one object in that group. So the set of the first elements of a relation is called its domain. Okay, so when we look at the first set in a relation, that is the domain. And the second set of the relation is known as its range. Okay, so domain is the first set, range is the second set. Now a function is a special type of relation where in each element the domain is associated with exactly one element in the range. So another way to think of this is for every x value, there is only one possible y value. And you can add that into your notes if you'd like as well. So we're going to look at a couple examples below. Some of them will be functions, some of them will not. So we'll take a look at two relations below. So for each of these, we have to identify its domain and range and then decide whether it's a function. So the first one they've given us here, they wrote the relation, and you can notice here that they wrote it in a set of ordered pairs. So we would have to start with its domain and its range. So when we write domain and range, we use these kind of fancy looking brackets here. Oh, mine is not quite. Try that again. Okay, so the domain for all of these, I'm just going to list the first element in each set. So orange, cheese, broccoli, milk, and kiwi. That would be the domain. So again, you'll notice that I wrote out the entire first set. That's our domain. And our range, again, we'll use these fancy looking brackets here, would be all of the second elements. And we only need to write them once each. So if anything is repeated, I just write it once. So I have fruit, dairy, vegetable, and then we'll notice that dairy and fruit are repeated, so I don't need to write those out again, and that's my range. Now, if I was to look at the second set here for domain and range, okay, my domain for the second example shown in my arrow diagram, I have the number 5, 6, 9, and 11. And for my range, I have baseball, basketball, hockey, soccer, and volleyball. Now, the second really important piece of information that I needed to do for each of these is decide whether the relation is a function. So the main part that I'm going to be looking at is the domain. I want to make sure that the domain is not repeated in any of the examples. So if I take a look at the first one, I have orange, cheese, broccoli, milk, kiwi. You'll notice that the domain is not repeated, so example A would be a function. If I look at the second example here, you'll notice that the number 6 is repeated. So the number 6 applies to both hockey and volleyball. So this would be not a function. So just to note that this one is not a function because again, you'll notice that one of the numbers in my domain is repeated. Okay, so for this x value, there's more than one possible y value. That's why it is not considered a function. So let's take a look at the next page. So there's a check question here. Again, I'd like you to try that one on your own. You can either pause the video now and work your way through the question, or you can do the check question later on to practice whether it's a domain or a range. We're going to take a look at the example at the bottom. So this is now at the bottom of page 258. So it says this table shows the masses of different numbers of Canadian quarters. So I'm given my number of quarters and my mass. So we know that again, the first set is my domain. So all of those numbers would be my domain. And the second set is my range. Now, if we look at this specific example, the mass of the quarters, or variable m, depends on the number of quarters, or variable n. So we use these terms in science, but we can use them in math as well. We could say that m is the dependent variable, and we can say that letter n is the independent variable. So the dependent variable in this case, the mass of the quarters, depends on the independent variable, which is my number of quarters. So the dependent variable will change according to a change in my independent variable. But remember, my independent variable is not affected by my mass, but rather the other way around. The mass, my dependent variable, is affected by the number of quarters, my independent variable. So let's flip over the page and take a look at these terms again, this dependent and independent variable. So here you can see we have, again, a relation. We have number of minutes represented by a small letter n, and we have a cost represented by letter C. So in this example, it says, why is the relation also a function? Okay, so why is this relation also a function? If you remember from the previous section, in order for something to be a function, we need to have no duplicates of our domain or no repetition in the domain. So it is considered a function because there is only one y variable for every x variable. Okay, remember we said there's only one y for every x. So this one says identify the dependent variable and the independent variable. So if we look at this example here, does the number of minutes rely on the cost, or does the cost rely on the number of minutes? You might have noticed that the cost is dependent on the number of minutes, making the number of minutes independent. Okay, so that means that my number of minutes is my independent variable and my cost is my dependent variable. And then the last thing they've asked me to do here is write the domain and range. So I'll start with the domain. Again, I'm just going to list all those numbers. So we have 10, 20, 30, 40, 50. Now the example down there shows ... Basically what that's saying is that it could continue. If you didn't include the ... though, that's all right. You don't need to include that. And my range is 2, 4, 6, 8, 10. Again, could continue if my number of minutes went up. Okay, so at the bottom of the page, there is a check for you to try on your own. Just like the last example we did, it's going to ask if the relation is a function. And then there's some more questions at the very top of the next page that go along with that. So you can either pause the video now or you can continue on with the check. And the last example I'm going to show you here is very similar to that skill builder that we did right at the very beginning of the lesson. So this example here says using function notation to find values. So we're going to talk a little bit down here about what function notation exactly is and how to use it. So it says here, Carmen works for a research company in a shopping mall. The equation P equals 5n plus 30 represents her daily pay, capital P in dollars, when she conducts n surveys. So the n is looking at our number of surveys. So it says describe the function and write the equation using function notation. So I'm going to show you what function notation is. We're going to use both of these variables and make it into an equation where we just have one. Okay, so we would say this means that the P of n is equal to 5n plus 30. Okay, so that function notation is very important. There was an example just above this in the notes as well, showing that function notation. Okay, so whenever they ask you to write function notation, you're going to use those two variables, and we're going to write the C of n or the P of n or whatever our two numbers are together. So the next part, what they've asked me now, is to find the value of P of 8. So, and then they ask, what does this number represent? So if we look at the P of 8, Okay, first of all, what does this number represent? Well, it represents what her pay will be. Okay, so what does this number represent? Her daily pay. So let's try putting that in. That means for her P of n, we're instead going to put her P of 8, and we're going to use the number 8 now anytime where we had an n previously. So the P of 8 equals 5, that means times 8, plus 30. So 5 times 8 is 40, and 40 plus 30 equals 70. So her daily pay will be $70. Okay, so that represents her daily pay. Now the next one, they said, find the value of n where your P of n is equal to 90. So that means where we had P of n previously, we're going to put the number 90 in. So let's try that here. 90 equals 5n plus 30. So just like we did before, we're going to rearrange to solve now for n. So we go minus 30 plus 30. We end up, or sorry, minus 30 and minus 30 on this side. Sorry about that. 90 minus 30. We end up with 60 equals 5n. And again, if we divide both sides by 5, we end up with n is equal to 12. So that number, n, remember, represented the number of surveys. So what this is saying here is this is representing our number of surveys. Okay, the number of surveys in order for her to make $90. So there's one more example here at the top of the next page. Okay, I'd like you to again try that one on your own. That's the check on page 262. And then you're going to complete the remainder of the questions for 5.2, the practice on your own. And you'll be able to check those. I will be posting the answer keys shortly up onto the Google Classroom, and check your own work as we usually would in class. Feel free to email me if you have any questions about this lesson, if anything isn't making sense, and I'll answer you as soon as I can. Have a great day.